Back up with example 4. On example 4, they're asking us to find all of our zeros. So this goes back to, I'm trying to think, we did something like this in Algebra 2. Have we done we haven't done anything like this yet this year. Yes, we did. Yeah, that's right. Okay, sorry, I'm trying to separate Algebra 2 versus Pre-Calc. We're doing a lot of the same stuff right now, and so I get confused on what I have taught where. So there's my confusion. So we did back in 2.4, we did a little bit of finding the zeros. At the time, do you recall what we were doing first when we went to find all of the zeros? What do we have to find first? Well, to get to factored form, though, because I certainly don't know how to factor that. Remember finding PRRs? Okay, so that's where we're going back to here, is we're going to go back to, okay, finding our PRRs, and then we're going to talk about options of how we can know which ones to try to kind of speed up our process, and then finding all the zeros and possibly writing it factored form depending on what the problem suggests. So as we look at this one, it asks us to find all zeros of f to the x and write it in its linear factorization. First of all zeros. How many are we looking for? This is an x to the 5th problem. So we are looking for 5 zeros. Okay. We're going to start with PRRs. That will give us an idea of some options to try. Do you remember how to find PRRs? Okay, P over Q, where P represents what? Factors of the constant, which is factors of 8 over factors of what? The leading coefficient. And my leading coefficient this time is the invisible 1 there. Okay, so factors of 8 over factors of 1. What are my factors of 8?
1, 2, 4.
Okay, so if you think in pairs, it's 1 and 8, 2 and 4. When we write them in order, 1, 2, 4, and 8. And with each of those, we're going to say plus or minus. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, all over factors of 1, which are plus or minus 1. Now, if we list these out officially, it's just the top numbers, right? Because it's everything over 1 in this case. So my PRRs are plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Okay. What do we do to narrow this down? Okay. Graph for some suggestions here. Okay. So if you would, go to your graph and see what does the graph suggest here? Yes.
-2, 1,
-2, 1, and 4. Sounds about right. You guys agreeing with her? Get a graph, check it out. Now, are those the only ones that are whole numbers, or are just those the only ones that exist? Those are the only ones that exist? So that means if we're looking for a total of 5, what's that mean about the other 2? They're imaginary, okay? So she says -2, 1, and 4, yes? Do I need to put that on the screen? You graphed on the calculator. These should be the places where the x-axis is crossing, yes?
Yes.
Okay. And just eyeball it, guys. I'm not looking for you to actually find them. Just eyeball it, okay? So, what do we do with -2, 1, and 4? Yeah. You're setting up with synthetic division here. It doesn't matter which one you start with. What do you guys want me to start with?
-2.
Just go in the same order.
Okay. -2. What goes next to -2?
1, -3, -5,
Did I get all those? 1, -3, -5, 5, -6, 8. Yes? Okay, you guys know synthetic division by now, right? Drop the 1, -2 times 1, -2. Add, multiply. Add, multiply. Add, multiply. Add, multiply. Add, and I quit saying the numbers because, hello, you're pre-calc. You guys can do the math, right? So you make a careless mistake.
Right.
Tanner found the careless mistake. Thank you. Okay. Okay, so I would like to believe we're probably good. I got a 0 remainder. So as we would have guessed, -2 works, right? Now what?
or 1. You take the bottom numbers and then do it 1.
Okay. So we're going to use 1 next. And one of the big keys here, remember, don't go back to the original. We're going to use our new numbers. This is incredibly important on this one. If you don't keep using the new numbers and you go back to the original, we're going to get in a position where we can't find our last 2 answers. So we're factoring it down. So far, we factored out the -2, which represents x plus 2. Now we're going to factor out the 1. So 1, -5, 5, -5, 4, and you don't need the 0. So now, drop the 1, multiply. Add, multiply. Add, multiply. Add, multiply. I got another remainder of 0, did you?
Yes.
Okay, so again, remainder of 0. We know 1 works, which means if we know 1 works, we know that creates the remainder of, or it creates a factor of x minus 1. Now what? -2, 1, and now keep going with the ones you're given. Using that new row of numbers again. 1, -4, 1, -4. Okay. Drop the 1, multiply. Add, 4 times 0, 0. Add, multiply, add. Shocker, guess what happened? It worked, yes? Now, with this in mind, what does that 101 represent? X squared plus 1, are you with them? We start off with x to the 5th, yes. That gave us x to the 4th. Divide, that gives us x to the 3rd. Divide, this gives us 1x squared plus 1, yes? What do we do with that to find our last 2 answers? Set equal to 0. So, what are you doing? Subtract the 1. Okay, x squared equals -1. We're going to square root both sides. When you square root both sides, what do we end up with?
Plus or minus I.
Yeah, plus or minus the square root of -1, but the square root of -1 is I. Okay. How many answers do I have? 5. Okay. Officially, it asks us to find all zeros. So if we're, listing our zeros, we found -2, 1, 4, positive I, and negative I, right? Now, more importantly, what did it ask us to do? Write it in its linear factorization. Okay, so knowing how to write it in all the factor forms. So, f of x equals. Okay, now, first of all, one thing I always forget here. We have all of our factors that we're going to gather. Always go back and check. What was my a value here? My a right there is 1. If a is anything other than 1, you do need to put that a value down there. And that will come up on the next problem, okay? But, okay, what does a 0 of negative 2 represent? What factor is that? Yeah, it's x minus negative 2, which is x plus 2. A 0 of 1, what does that represent? X minus 1. A 0 of 4 is represented by x minus 4. What about the 0 of I? How are you going to represent that? Well, but if we, kind of a debatable moment, but if we technically go ahead and factor that down, if we're just worrying about the I, how do we represent an I? If you just put the I in there.
Just the like
X minus I. Okay, so what this book does, I believe, is they go ahead and factor it out and say x minus I. And then if you have a negative I, how is that represented? X plus I. Now, I agree. Where did those come from? They did come from x squared plus 1, and that is a factor. But the catch here is it says linear factorization. When they say linear factorization, every factor has to be a linear factor, so x to the first. Okay? I think in the Algebra 2 book, I don't think they factored it down into the x minus 1, x plus, or excuse me, x minus I and x plus I. If the directions say linear factorization, yes. Because linear means my highest power is x, they're all x to the first is what they're looking for there. Okay? Okay, questions on that one? That was kind of the review extent. Are we ready for example 5? Example 5 tells us the complex 0, z equals 1 minus 2i, is a 0 of f of x. Find the remaining zeros and write f of x in its linear factorization. Notice they gave me a 0, yes? Okay. Do me a favor. Pop this into the calculator real quick. I'm skipping over the PRR step. I have my reasonings. I'll explain it here in a moment, but pop this into the calculator. What's the problem? There's nothing, is there? Okay, which means, recheck what you typed, there should be no real zeros. And if there's no real zeros, that means there's no x-intercepts. Okay, so now I skipped PRRs, and here's the deal. Here's my clue. Here's your clue as to how can we just skip PRRs and jump straight into it. What did it start off telling me? 1 minus 2i is a 0. They gave me one of the zeros, folks. That's the reason they gave me one of the zeros is because we can't really start this problem otherwise. Okay? With the fact that they are all 4 going to be imaginary. Which, by the way, I said 4. Do you agree that there are 4 zeros? Yeah. Okay, so we are going to have 4 zeros here. Now, the first one we're going to work with is 1 minus 2i. Okay?
If 1 minus 2i is a 0, would 1 plus 2i be 1?
You guys remember the, what is it, complex conjugate zero theorem on the front? Yeah, complex conjugate zero theorem. If a plus bi is a 0, then so is its conjugate. So what were we just told? 1 minus 2i is a 0. So what else do we know? We have to automatically use 1 plus 2i. So now we're up to how many zeros? We're up to 2, which means we've got 2 more to find, which we can probably find in the end. Okay, guys, I've got a lot of work to fit in this space just because of the way it works out. What's the first one we're going to do synthetic division with? We're going to put 1 minus 2i in the box. Now, word of warning. Spread your first row of numbers out as you write it. You know, normally we're just putting a number under a number. Just spread them out a little bit. So what are my coefficients that I'm putting? 4. What comes after 4? 0. What comes after 0? 17. Then what? 14. 65. Do you see what I mean that I spread mine out a little bit more than normal? I'm doing that for good reason. Okay? Now, with that in mind, folks, okay, let's go. What do we do first? Drop the 4. Then what? We're going to multiply. What is 4 times 1 minus 2i? It's a distributive property, yes. 4 minus 8i. Okay? This is why I spread my numbers out a little bit, right? What are we going to get when we add here? 0 plus 4 minus 8i is 4 minus 8i. Now what? We have to multiply. What are we multiplying? We're foiling, yes? Okay? So we are foiling. Sorry to be the bearer of bad news. I'm going to go down here, and I'm going to FOIL down here. So I'm foiling 1 minus 2i and 4 minus 8i, yes? Okay, FOIL with me. 1 times 4, 1 times minus 8i, negative 2i times 4i, and negative 2i times negative 8i. Barring I didn't make mistakes, are you guys with me? 4 minus 8i plus 16i squared. Clean that up before we put it up in our problem. What's that clean up to be?
Minus 16.
So we have the 4 out front. Negative 8i minus 8i is going to be negative 16i. What about this 16i squared? It is what?
Minus 16.
It's minus 16. So then 4 minus 16 is negative 12. So how about negative 12 minus 16i, yes? What are we doing with that negative 12 minus 16i? It goes here underneath the 17. More and more I'm showing you why I suggested you space it out, right? Okay, now what? We're going to add. Add like terms, right? What do we get when we add that? Okay, are you guys with them? You add that, you get 5 minus 16i. Now what? We're going to FOIL again, aren't we? So this time I'm doing 1 minus 2i times 5 minus 16i. So 1 times 5, 1 times minus 16i, negative 2i times 5, negative 2i times negative 16i. So I have 5 minus 16i minus 10i plus 32i squared. I could agree with that. Negative 16i minus 10i is negative 26i. And then you have the 5, and a plus 32i squared is minus 32, right? So 5 minus 32, negative 27. Okay. Let's see. Put this back where, let's see. Negative 27 minus 26i is going under the 14. What is that when you put it together? Negative 13 minus 26i. And FOIL again. It's going to work out magically. I promise. So now I'm foiling 1 minus 2i and negative 13 minus 26i. So FOIL 1 times negative 13. 1 times minus 26i, negative 2i times negative 13. So, and negative 2i times negative 26i. Okay. Well, what happens? Negative 26i plus 26i cancels. Negative 13 plus 52i squared, so negative 13 minus 52. Guess what negative 13 minus 52 is? Negative 65. I told you it would magically work out, yes? Because now we get a remainder of 0. Okay, so what did we just verify? We verified that a remainder of 0, so 1 minus 2i works. Yes, but it will be better this time. I promise. It works out 100% better this time.
If they tell us that it's a 0, do we have to check it?
Yes, because I need the answers. I need this, and most importantly, I'm going to need this one over here to find my final 2 answers. Because right now, I only know 2 zeros. I need 2 more zeros, and they're going to come from whatever equation I end up with. Okay, so what I did right now is I factored out the 0, 1 minus 2i. Now I'm getting ready to factor out the other 0. So my other one is 1 plus 2i. So yeah, well, I call it checking. We're technically doing a little bit more than checking. We're factoring. So remember, what am I putting in here? New numbers, yes? Okay, I promise it works out better. You're not going to be doing the yucky foiling. So 4 minus 8i, 5 minus 16i, negative 13 minus 26i, and you don't need the 0. Okay. Drop the 4. 4 times 1 plus 2i. We're distributing 4 plus 8i. What do we get when we add that?
7.
Not exactly 0.
4.
8.
8.
The 8i's cancel out.
Oh.
Minus 8i plus 8i cancel out. But the 4's do not cancel out, correct?
Yeah.
4 plus 4 is 8. Okay. Keep going. Now we're doing 8 times 1 plus 2i. What's 8 times 1 plus 2i? 8 plus 16i.
Oh, this is cool.
I told you this one is 100% better. I know you guys didn't want to believe me. You're like, she's just fibbing.
I believe.
But it's nice.
I believe you.
In comparison to the last one, this is much better. Okay, what do we get when we add here? 5 and 8 is 13, but my 16 i's cancel out. 13 times 1 plus 2i. 13 plus 26i. What happens here? This time it truly does cancel, doesn't it? We get the 0, we expect a remainder of 0. We've, not shockingly, we know that 1 plus 2i works. Now, here's the deal. You need this right here to find your final two answers. That's why we did all this. Not because there was a question of whether these two worked, but I need to find my final two answers. So, what does 4, 8, 13 represent? Set it equal to 0. How am I going to solve this? Nope. Yep. Here's the deal. Can it factor? You can try and factor if you want, but you can't product of A, see this, or slip and slide it. It's not going to factor, folks, because remember, these aren't going to be real, are they? We're going to get imaginary. So this is a quadratic formula situation. So x equals negative b.
Plus or minus the square root of.
So negative 8 plus or minus the square root of.
B squared minus 4 times AC.
So 8 squared minus 4 times 4 times 13 all over.
What'd you? 2 times 8.
2a. I was like, I lost him. What happened? He was giving me my quadratic formula.
Don't worry.
Okay, negative 8 plus or minus, well, 64 minus whatever 16 times 13 is. What are we going to get here?
208.
So 64 minus 208, negative 144. All over 8. Okay. Negative 8 plus or minus. What about the square root of negative 144? Square root of 144 is 12. Square root of a negative makes it I. So 12i all over 8. Now, I am going to go one more step here in how we express this answer. A, because it reduces, and B, because we have to put this in factors, okay? What do you know about negative 8 over 8? Plus or minus. What do you know about 12i over 8? Or most importantly, what about 12 over 8? 12 over 8 reduces to 3 halves I, or 3i over 2. Okay, I mean, 8 divided by 8 is 1. 12 over 8, they both divide by 4, so it becomes 3 over 2. You can say 3 halves I or 3i over 2. Okay, so here you have your other two zeros, yes? Okay, now, not quite done, because we have to write this in linear factorization. And there's a few tricks here to get it to look the prettiest, okay? But there's some, you know, if it's just me gradient, there's a couple different ways I'll accept it. Now, I'm determined not to forget it. I mentioned something about the A value on the last problem, yes? Always go back. We have factored this out, but along the way, we have lost if there was any value up front. We've lost that. What was our A value? In other words, A being the leading coefficient, essentially, the number in front of the first term. So we're going to have a 4 out front. Okay? You good? Now, how confident are we from yesterday? Remember, when we do factors, it's x minus the 0, right? So I'm going to go back to the one they gave me first. If I'm going to write this, one way I wrote it yesterday, and I'm going to erase this, is I wrote it as x minus the quantity 1 minus 2i yesterday, didn't I? But can we clean that up in one step so I don't have to write it twice? What it is when we do x minus the quantity 1 minus 2i, it becomes what?
Plus. No.
Minus 1 plus 2i.
Minus 1 plus, yeah.
Okay. So x minus 1 plus 2i. Okay, now what if we do 1 plus 2i? It's going to be x minus the 1 and minus the 2i. Are you with me? Now, let's come over here. We have, what do we have as zeros? We have negative 1 plus 3 halves I, and we have negative 1 minus 3 halves I. So let's start with the negative 1 plus 3 halves I. X minus negative 1 becomes plus 1, and then minus 3 halves I. And then do the same thing with negative 1 minus 3 halves I. You're subtracting it. So it's x minus negative 1, which is plus 1, and minus negative 3 halves I, which is plus 3 halves I. Now, while this is an answer, and not a half bad answer, the book is going to clean this up one more step. Okay? It is in linear factors. What is the piece of this that you might hesitate, are we allowed to leave? There's what in a couple of these factors? A couple fractions, yes? Now, it's not that you can't leave them, but I'm trying to show this to you because you're going to see this in homework a little bit. It just is a I don't know if I want to say coincidence or whatever, but how do you get rid of a denominator of 2? You multiply by 2, yes? How many? We have a denominator of 2 here, and we have a denominator of 2 here, yes? So we really need to multiply by 2 2's. What do we have out front? I don't know if it's coincidence or what, but we have this 4. And so what the book will do is it'll take this 4, and it will multiply a 2 to each of these parentheses. Okay? If we're multiplying a 2 to each of those parentheses, that means the 4 out front is just going to disappear. It's going to drop out. Because we're taking that 4, we're splitting it up into 2 2's, which is still 4. 2 times 2 is 4. And we're multiplying it into those specific factors. So, final answer. The 4 is going to multiply out, so it's going to be gone. We still have the x minus 1 plus 2i. And I have the x minus 1 minus 2i. Now, this third parenthesis here. We're not multiplying just the fraction by 2, but the whole factor, yes? What do we get when we multiply this whole factor by 2? Okay, 2x plus 2 minus 3i. And then we're going to take that other 2 and multiply that last factor all by 2. So we multiply this last factor all by 2. It becomes 2x plus 2 plus 3i. Okay, guys. I know that's a lot on that last one, but I hope you can look at it and understand it does make it look a lot neater if you take that 4 and break it up and distribute it to the 1/2. Okay? That is essentially the purpose there. Okay, guys. I went ahead and did notes today. The only reason I did this is now you get Monday as a work day. Okay? You've seen some of the big problems we saw in notes. Are you going to see some big problems like that in homework? You are, okay? So this homework is due on Tuesday. So Monday will totally be a work day. Okay, work day on your homework here.